Hi there. Thank you for joining us for today's event entitled Rocketing to the Future of Cloud-Defined Storage. My name is Scott Lowe and I'll be your host for this special launch event for Nebulon. Before we get started on exactly what we mean by cloud-defined storage and introducing Nebulon to the world, we have some housekeeping items we'd like to cover. First of all, we have a number of prizes to give away today, including 9 Amazon gift cards and an e-bike that we'll give away at the end of the event. There are some rules you'll have to follow that we'll talk about on the next slide. If you have any questions at all about anything you hear today, please make sure to use the questions button in your console. We will be taking questions live during the event. We want to make sure we get to all of you. Take a look in the handouts section of your console as well, as there are some resources available for you to download. Now, let's talk about prizes. In order to win prizes, you must be live on the event in order to win. If you'd rather not take the prize, but instead like to make a donation of an equal amount to a selected charity, please let us know. We've had a number of people do that over the years, and frankly, at this point in our history, it's probably a nice thing to do if you're able to. If you do choose a prize, you'll have to submit an IRS W-9 form to Actual Tech Media. The IRS always wants its cut of a gift over a certain value or a prize over a certain value, so we have to send you that form in order to win prizes. And we will reach out to prize winners via email after the event. For full prize details and information about our policies around prizes, please visit the link you see on your screen. We have a really jam-packed agenda today to help introduce cloud-defined storage from Nebulon to our audience. You're going to learn from Nebulon folks about what cloud-defined storage actually is, how it works, and you're going to get a demo about how it can work in your environment. After that, you'll be treated to a panel discussion moderated by our very own David Davis, and we'll also get an analyst perspective from me towards the end of the event. And after that, we'll do some prize giveaways. We are here today to talk about Nebulon coming out of stealth with their cloud-defined storage solution. To that end, I'm going to hand it over to Simak Nazari, who is the founder and CEO of Nebulon. Simak, take it away.
Great, thank you so much. We are here to introduce Nebulon today. It's really a company that is founded by a number of 3PAR, ex-3PAR executives and veterans of the storage industry. David Scott, who is our executive chairman, he was the 3PAR CEO and HPE Storage SVP and general manager. He's on a number of boards, AppDynamics, OverOps, Veritas, and Token. I'm Simak Nazari, the chief executive officer of Nebulon. I was, before that, 3PAR chief software architect, and after the 3PAR acquisition, an HPE fellow. Sean Atati, which is our CTO, he was a platform architect at 3PAR prior to that, and an HPE 3PAR chief hardware architect after the HPE acquisition. Craig Nunes, who's our chief operating officer, he was a 3PAR CMO and HPE Storage Global Marketing VP. The company was founded in November of 2018, and we have offices in Silicon Valley, Bellevue, Washington, London, UK, and Belfast, Northern Ireland. The engineering talent comes from storage side of it, comes from 3PAR, cloud from Snap. We have filed a number of patents and in the areas of cloud and security. So what is Nebulon? Why are we building a new company? This a set of themes over time is what we've observed when we talk to the CIOs. And what they really are looking for are a streamlined architecture with far fewer moving parts. This is something that they believe would lead to operational simplicity. And at the heart of it, it starts with using existing industry standard infrastructure components, such as the existing drive slots in the servers that they already buy and deploy in their data centers. And along with that, commodity drives, which are available from multiple vendors very economically, that can be deployed at scale. The customers are looking for fewer agents and software components to be installed under servers, because every time you add an agent, it adds to additional complexity and potential negative interactions. Application owner self-service is really what the new design center should be. This is how you achieve scale and agility in the data center. And ultimately, the enterprise IT still needs enterprise-wide visibility and automation. And they can achieve that by having API at scale and really a fleet management model. And this is how enterprise IT needs to evolve to be able to compete effectively with cloud infrastructures. So how are we building this? We are building what's called an cloud-defined storage. At the heart of it is really on-premises server-based enterprise class storage that doesn't consume any of the server CPU or memory resources. And this is all defined and managed through the cloud. It's really made up of two components. It's a secure AI-driven cloud-based control plane, which we call Nebulon on, and an application server that is hosting a PCI-based service processing unit, which replaces traditional RAID or fiber channel adapters. The idea behind the cloud is to get management at scale and continuous improvement by having the entire management plane in the cloud. And the services processing unit really modernizes the storage controller, much like the GPUs have modernized the standard, traditional graphics controller in servers, and bringing a class of functionality that was not possible prior to that. All of this comes out to about half the cost of expensive enterprise storage arrays by leveraging less costly and commodity server SSDs. So let's talk about the use cases for cloud-defined storage. Craig, take it away, please.
Great, thanks, CMAC. Yeah, so what is the appropriate application of this cool new technology? So as CMAC mentioned, cloud-defined storage actually can deliver these enterprise class data services for both local storage and shared storage. So what that means is for your modern applications like a NoSQL, message brokers, containers that depend on storage local to the server, cloud-defined storage is a wonderful way to achieve great data management. However, if you have more traditional workloads like virtualization infrastructure, clustered databases, which depend on shared storage, cloud-defined storage addresses that as well. So it's a wonderful technology that can address kind of where you're at and where you're going. In talking about cloud-defined storage with a variety of customers, I thought I'd just cover a couple of situations where customers are looking to apply cloud-defined storage and what they're getting from it. One is a US auto manufacturer. They're in the middle of modernizing their array-based VMware private cloud. And in the shift to cloud-defined storage, they anticipate saving about $300,000 per rack, while being able to now manage and automate their private cloud at scale. Another example is a service provider, one of the largest service providers in Europe, and they deploy their infrastructure in basically a rack at a time, 20 servers with a storage array at the bottom 3U of that rack, and that bottom 3U costs them 2/3 of what they spend on that entire rack. And so they view cloud-defined storage as a way to get that array out of the rack, move to a server-based deployment approach, reduce costs for their new Kubernetes service, and they can do it all without introducing a new vendor in the data center. In fact, they can take one out. Finally, a financial services use case. This is a company that envisions a fully self-service infrastructure for its application owners. And the use of cloud-defined storage allows their app owners to accelerate new projects, to get what they need when they need it. It frees up build teams, connectivity teams, and storage teams to be redeployed into higher ROI activities, software development, and the like. So hopefully that gives you a taste for the power of this new technology. How do you get cloud-defined storage? Look, it's going to be available from your server vendor. No need to introduce a new vendor into your data center. Both the SPU and the cloud subscription are effectively server options on 2U 24-drive servers. All quotations come from your server vendor. All support contracts, all, again, are with your server vendor, right? So a great way to buy. At this point, might make sense to kind of double click into the technology, and to do that, I'll introduce Tobias Flitch, who is our head of product here at Nebulon.
Thanks, Craig. So as CMAC mentioned earlier, cloud-defined storage is composed out of two major components. The data plane, which makes use of services processing units in your application clusters, and the control plane, which sits entirely in the cloud. Now let's first have a closer look at the data plane and the services processing units, or in short, the SPU. Now, when customers buy servers from their favorite vendor for their application clusters, they usually configure these servers with either a RAID card or a fiber channel HBA. However, with cloud-defined storage, these cards are replaced with a services processing unit from Nebulon. Nothing changes with the application cluster. It's still a group of servers that have clustered applications installed. The only difference is that every server in the application cluster, or also called NPod, now is equipped with this SPU. It's a full-length, full-height, double-wide PCIe card, so it nicely fits in your standard 2U rack mount server. Now there's no storage in this card, and it connects to the SSDs in the server, much like a RAID card would. And it then presents shared or local volumes to the operating system or the hypervisors in the application cluster. Now each server in this NPod would use its own SPU to access shared or local storage. So there's no external storage protocol like iSCSI or fiber channel at play here. But the SPU is equipped with network ports. So to be specific, these are two redundant 10 or 25 gigabit Ethernet ports to exchange data between the cards in this application cluster. These network ports are not visible to the operating system, but they're exclusively used by the SPU to communicate with other SPUs in the application cluster. And what this network connection allows us to do is to provide shared, high available storage to these servers. There's also 1 gigabit Ethernet management port available on the card, which connects the SPU to the cloud control plane, which I'll talk about in a moment. When you think about the SPU, don't confuse this with an accelerator card. So some vendors will provide you an accelerator card, and they do exactly that. They accelerate functions of some software that is running on the host, which of course has to be adapted to make use of the acceleration functions. The SPU, on the other hand, is a fully featured computer. Right? Think about a single controller of an external storage array that was shrunk into a PCIe form factor and then plugged into the server. So it does not require any software on the host, and it looks to the operating system just like a regular SAS HBA. This means it works just with the standard operating system drivers, and you're not tied to any specific operating system or to any particular hypervisor. The SPU provides all of the data services known from enterprise storage arrays. It does deduplication, does compression, erasure coding, encryption, snapshots, data mirroring. So it effectively provides the features of an external storage array instead of just accelerating some software in the server. The other benefit of not having any dependency on the operating system is that this card is a separate fault domain. So if the operating system is down for patching, or if there was a crash or a blue screen, the storage services are still operational without any performance degradation, any data rebuilds, or any failovers. The SPU features a powerful CPU, which makes this really a pretty powerful controller that can deliver all flash array latencies. And since all of the data processing is done on the card's CPU, server memory, server networking, and the server CPU resources can be given back to the applications or the virtual machines on the server, allowing better density compared to all of the solutions that run software on the server. Now with this card, we make use of a scale-out architecture, where at general availability, we plan to allow customers to combine up to 32 SPUs together in a pod to scale performance and capacity into the petabyte range. And of course, they can do that at a lower cost compared to an external storage array, since we're using the more affordable SSDs in the server, and since you don't have to implement and pay for the complex and expensive SAN infrastructure. Now, we don't expect customers to manage all of these features of this SPU. We want to help administrators and application owners who are self-servicing and self-provision infrastructure and may not be storage experts by configuring the SPU and NPODs application aware. So with the right settings for the right application that is in use. And we do that by the use of what we call application templates. Much like hyperconverged infrastructure helps VMware administrators to bootstrap their hypervisor clusters, we help other application owners to do the same. So that a Kubernetes administrator has the right config for Kubernetes, a MongoDB admin has the right config for MongoDB, or a VMware administrator for VMware, etc. So at this point, you're probably thinking about hyperconverged infrastructure and how cloud-defined storage compares to it. Both make use of the storage in your application server, and they eliminate the need for a SAN. And they both allow self-service provisioning of infrastructure and storage by the application owner. But there are some key differences that I want to bring your attention to. So the data service and cloud-defined storage run entirely on the SPU, and they don't have any overhead like software-defined storage does on the host. This means you buy fewer servers and you save on licensing cost, as you're not burning server resources for storage services. Cloud-defined storage is operating system and hypervisor agnostic, which makes it applicable for more than just virtualization. And there's still plenty of workloads out there that are not running on a hypervisor or a container platform. So with cloud-defined storage, you're not creating yet another infrastructure island, but you can use it really for a variety of deployments. It's a separate fault domain, as I mentioned earlier, from the hypervisor operating system, which means you can reboot your server, you can patch the server, and your storage performance or reliability is not impacted by that. Similarly, you can update the storage services without bringing down any of the application server. From a performance perspective, the SPU makes use of NVRAM, which allows for better write latencies on one hand, and we can optimize how we write to SSDs. This allows us to work with SSDs with lower endurance compared to write-intensive drives, and that, of course, further brings down the cost of this solution. Additionally, by relying on NVRAM as a write cache, this allows us to create heterogeneous application clusters very, very easily, which means that you can scale compute independently from storage. For example, you can have a mix of servers where some have capacity and others have zero capacity, as you just want to add some more compute. Now with Nebulon cloud-defined storage, as mentioned earlier, the SSDs in the servers are attached to this SPU, which means that the SPU can facilitate drive updates automatically. This is transparent to the host because there's a virtualization layer in between. and the SPU can do that at a very, very large scale. And this is actually facilitated by the cloud-based control plane, which we call Nebulon. So instead of managing each server or cluster individually, the cloud-based control plane gives you the tools to manage and automate your entire infrastructure at scale a lot easier. And this is actually a very important point of cloud-defined storage. You control your infrastructure through a cloud control plane, and we call that the cloud control plane Nebulon. Now, when you look at a traditional storage system, you'll find a small portion of the software being the I/O stack. This portion is highly optimized and small because it really needs to be fast. The larger portion is the management stack. With cloud-defined storage, the entire management stack really lives in the cloud and is provided to customers as a service. This means it's always up to date, and customers can make use of new features instantly rather than waiting for months until they got an update and they have patched all of their arrays or hyperconverged clusters in the data center. And since the management stack is in the cloud, we can easily enrich it with additional insights that we get from machine learning. So when you administrate your infrastructure or automate your infrastructure, you can do that with AI assistance. What really remains on the SPU is just the small I/O stack, which, by the way, rarely changes once it is really hardened and robust. This means software on the SPU is lightweight, there are fewer updates to it, and when there is an update, they're super quick, which also means they're non-disruptive to the applications on your servers. So think of the SPU as the I/O storage controller, and that the intelligence sits in the cloud control plane. Of course, that means there's a lot stronger focus on the cloud, specifically around reliability and security. This is why the cloud is built disaster tolerant. We use multiple availability zones to ensure that the cloud is always available, and we have designed the SPU to continue to operate even if there is loss of network communication between your data center and the cloud. Now, from a management perspective, we secure all management actions with role-based access control to ensure that only the authorized users can work with your systems. We also audit all management actions in the cloud, so you have really a log of who did what and when. Now, all data in cloud-defined storage is encrypted. We encrypt user data as it is stored on the SSDs in your servers, and that data actually never leaves your data center. Right? Management, control, and telemetry data is encrypted between really every component that is involved. We encrypt between the browser and the cloud. We encrypt between the SPU and the cloud. We encrypt between the browser and the SPU. So basically, between every communication endpoint. So security was on top of our minds when the cloud control plane was built. And that security concern led to what we call a security triangle. What it does is that it ensures that through a clever exchange of securely signed tokens between the browser, the SPU, and the cloud, that only users that are within a customer's firewall can actually make changes to the infrastructure. This ensures that our solution is no less secure than an on-premises management station, but customers get the benefit that the control plane sits in the cloud. Now, by managing infrastructure through the cloud, we can really give customers value beyond just being an affordable server-based data storage solution that doesn't suffer the restrictions of a hyperconverged infrastructure. As many other storage vendors in the market, we collect tens of thousands of metrics from storage, the server, and if the customer chooses so, from the application. Now, this cross-stack diagnostic data is streamed in real time to the cloud control plane, where the customer now has a central view of their infrastructure. With all that information in one place, customers can then start to answer otherwise difficult questions they have about their infrastructure, like which applications are performing the best, which applications are performing the worst, where in my infrastructure do I have resource constraints, When will I run out of capacity? Where in my infrastructure can I provision additional workloads? Or which line of business is using how much of my data center resources? Now, since all of this data is available immediately in Nebulon On, customers can answer these questions in real time, and they don't have to come up with and implement complicated scripts that are querying all of the devices they have in their data centers individually. But we didn't stop there. Unlike other cloud-based monitoring systems that are built for providing you these reporting capabilities and help customers to troubleshoot their performance or capacity issues related to storage, Nebulon On also gives you the tools to administrate your infrastructure. Now, it's true that applications become more and more complicated, especially in a world of microservices and distributed applications. Each application has hundreds of knobs to tune, and you quickly get to a point where it's nearly impossible for a human to keep track of all of the configuration parameters, all of the statistics of each of these applications, yet to configure them in the best way for the best results. So a machine is needed to make sense of all of this data. Now, with artificial intelligence applied to all of the metrics and configuration information that is collected from storage, servers, and applications, we can learn and predict application behavior, and we can help customers resolve issues quickly. And we can even avoid issues before they really hurt the business. Now, with administration capabilities right in the same tool where we detect these issues, we can not only notify the customer about these issues, but we can allow them to immediately fix them without pointing them to a different tool or a different console. The same learnings from AI and really fusing them with the best practice guidance that we get from ISVs is what enables a zero-touch provisioning experience for customers. So when application owners self-service provision their infrastructure, the experience is much like picking a service from an application catalog in Azure or AWS. They can make use of a customizable catalog of application templates that would automatically provision the infrastructure for their own applications in their data centers. The key difference is really that this is done using your on-prem servers, and that the templates are constantly improved and optimized based on the observed workload, your workload. So when you deploy a new application, or if you scale an existing application, this is done tailored to your specific application workload. Lastly, the cloud control plane in Nebulon tremendously simplifies automation. In fact, this is a common theme that we hear from customers we talk to. Does it have an API? And the answer is yes. Yes, it does. A single API endpoint. When you automate with cloud-defined storage, you don't need to have an inventory of IP addresses, credentials of your systems, and you don't have to query and call each and every system in your data center. Instead, you call and control all of your systems from a single URL in the cloud. And when we mean control, we mean every aspect of the product. There isn't a single product feature that you can only control through a GUI or a CLI or some third-party application. Remember when I talked about the cloud being always up to date because it's delivered as a service, and that updates to the lightweight storage operating system on the SPU is super quick. Combine that with automation capabilities, and you can patch or update your entire cloud-defined storage infrastructure automatically with less human error. And it really doesn't matter if you do it with just a few systems or with 1,000 systems. So ease of use for this solution was a key design criteria. Management of and operations of this solution should be simple on day one as well as on day 1,000. So for the continuous operation and simplicity on day 1,000, we provide customers with these infrastructure insights so they know exactly what's going on in their infrastructure in real time. We do predict issues, we help them troubleshoot, and we give them the ability to fix these issues in the same tool, and we provide them with a powerful API for automation opportunities. For the simplicity on day one, we provide customers with the application templates. Now, application owners or really anyone that really needs infrastructure are not required to be storage experts. In fact, cloud-defined storage will help you make the right decisions on storage depending on the application that you want to run. Think about what hyperconverged infrastructure did for VMware administrators. It's just a simple wizard where you select a couple of vSphere servers, you create your clusters, and you can start provisioning your VMs. This is a great experience, a great getting started experience, I should say, for VMware administrators. Now with cloud-defined storage, this experience is similar, but the key difference is that it works beyond just for VMware administrators. So if you're a Kubernetes administrator, if you want to provision servers for your MongoDB or another cloud native database, this simple getting started experience is also available for you. How? Now in Nebulon On, you can make use of a curated collection of reusable application templates. And they define the server to storage configuration for specific applications. So when you want to self-service provision an application, you pick your servers, you pick a template, and then you get your infrastructure provisioned as your application needs it. Now, of course, customers can append their own templates to this collection if they have, let's say, special needs, or if they want to create a template for their homegrown application. But they can use this application template approach to really provide application owners a way to easily and consistently and repeatedly roll out their own infrastructure for their own applications. As an example, what an application template would define for a user, it would provision the right amount of volumes and their size considering the application's data reduction savings. It would set the right data redundancy and protection levels. It would apply a good snapshot schedule, and it would define which servers should have access to which data. What application templates also allow you to do is automatically provision the operating system on the servers. Now, since we're a card in the server, or since the SPU is a card in the server, it can use a volume, so the server can use a volume from cloud-defined storage as a boot device without the hassle of setting up boot from SAN, right? What that means is that all of the enterprise data services are also available for your boot volume. You can make use of snapshots or cloning to create and use a golden image, and you can then quickly roll back your operating system for a DevOps use case, or you can create snapshots before a critical operating system or application update. I personally think this is really powerful. You can change the identity of your servers and your application clusters very easily just using these application templates. So one day your application cluster is running VMware, the next day they run Kubernetes. So you'll gain this infrastructure composability that really is just a button click, meaning that you just select a different template from this catalog. Now, I mentioned earlier that these application templates are constantly optimized. With a shared storage array that serves multiple different applications, the workload seen by the array is really just noise, right? With the concept of npods, we have a very good understanding of the workload of a single application cluster. Since one application cluster is one pod, there's a lot less noise in the workload patterns, and our machine learning can be a lot more accurate. What that means for customers is that they may get more precise recommendations compared to what they get from external storage arrays, and templates that are better tuned to individual applications and customer workloads. Now, apart from monitoring workloads and the optimizations from telemetry, there are just some essential configuration rules from application vendors that the application templates would apply. As examples, I have these 4 deployment options. Remember that cloud-defined storage enabled by the services processing units in the application servers doesn't have any dependency on the operating system or the hypervisor. So it's really flexible in terms of applicable use cases. It works for modern cloud-native workloads, for containers, virtualization, but also for bare metal workloads. And when you look at these example applications here, they all have different demands on storage data services. MongoDB, as an example, for a cloud-native application, it uses a scale-out approach where the application distributes data across multiple servers for better performance and for capacity scaling, but also to provide data redundancy. In this example, the application takes care of resilience itself. So the application template for MongoDB would configure the storage without data redundancy. However, MongoDB does not have built-in snapshots, so MongoDB users would have long backup and recovery times for the databases when they would just use regular local storage. But with cloud-defined storage, they can make use of instant protection and recovery facilities provided by snapshots. Now, all of this is embedded in the MongoDB application template. Now, for a Kubernetes use case, you might want to run a single instance container or pod that requires highly available persistent storage, which is, of course, only available on one host at a time, wherever Kubernetes schedules the pod. But more importantly, after applying a Kubernetes template, customers are able to make use of a CSI driver to provision, orchestrate volumes directly from within Kubernetes itself. And then for VMware, of course, the default is that all servers in the VMware cluster have access to all storage volumes, as it would be the case with a traditional storage array. You could have a template that is for development use, so it doesn't provision volumes with data redundancy, and you can have a template that is for production use, giving you the mission-critical resiliency for your storage volumes. So depending on the application type, users that are provisioning infrastructure pick a template, and Nebulon will define and implement a storage layout that best fits the selected application. So users don't have to worry about and think about any of the storage artifacts. So when app owners are provisioning and operating infrastructure with Nebulon cloud-defined storage, they don't necessarily have to manage and monitor individual volumes. Instead, they provision applications using the templates I described earlier. They just pick a template from a catalog and the on-premises servers that they have, and they want to use for the application clusters. And then the template ensures that all of the volumes and all of the storage artifacts are there with the right settings, and that these settings are tuned according to the needs of the application. Now that's for day one. And then during operations, the AIOps features in Nebulon provide the actionable recommendations for the application owners, specific to their application. So, and they can use the same tool that they use from which they get the recommendations to also fix any of the issues that are highlighted to them. As an example, assume that if a workload is imbalanced between the application servers in a cluster, they could identify this issue in Nebulon in the cloud control plane right away, and then they can use the same tool to take action. So they could immediately initiate a rebalancing from the same UI they were using to get the initial issue. Now, when the application owner actually runs out of resource, or the cluster actually runs out of resource in the cluster, and they need to, let's say, scale out, the only thing they really need to do is add a new SPU equipped server. And this new server will automatically adapt the right configuration as it is dictated by the template and by the workload that is observed in the pod. Now here, it doesn't really matter if the server the user is adding has a different storage configuration. It could be that the application owner needs just additional compute resources, but no storage capacity, and that can be easily done by just adding an SPU-enabled server. Now, from a troubleshooting perspective and predictable infrastructure, the application owner doesn't have to worry about competing resources. The app owner owns the complete infrastructure stack, compute and storage. So they don't have to share the storage layer or a SAN with some other application. They don't have to worry about coordinating maintenance windows or worry about noisy neighbor situations caused by other applications. It's just their application cluster on that infrastructure, which makes managing it a lot more predictable. This also helps Nebulon to better monitor individual application clusters and give the app owner a better recommendations, higher quality recommendations for their workloads. And this is a lot easier to do when you don't have to deal with the noise of many different application workloads on a shared storage platform. And then, of course, when you're managing not just one application cluster, but dozens or hundreds of clusters, you no longer need to query all of them individually. You just connect to a single API or a GUI if that's your preference, and you get full visibility across your entire infrastructure. That allows you to better monitor and control your applications, and you can make sure that all of the relevant application policies and settings are adhered to. Now, I think it's time to stop talking about the theory and show you a demonstration of the management experience of an application owner that is administrating their infrastructure using Nebulon cloud-defined storage. So let me hand it over to Martin Cooper, who's our head of our solution architects, to give you a demonstration about the management experience that an application owner would experience using cloud-defined storage. Martin, take it away.
Hi, my name's Martin Cooper and I'm the Senior Director of Solution Architects here at Nebulon. Today I'm going to take you through a brief demonstration of the Nebulon on cloud using our graphical interface. Our solution uses an API first design, which means that all capabilities of the product are also available for programmatic management using comprehensive SDKs. So if you have any custom management or reporting needs, that can be done using our API. But for now, we're going to stick to the UI, and without any further ado, I will jump into the demo. Every user in an organization has unique credentials, so they can securely log on to their company account, and they can only administer infrastructure that they're authorized to. In this demo organization, I'm logged in as a super user, which grants me unrestricted access to infrastructure within this specific organization, and I can show you everything that's going on. This is the overview page in Nebulon On, and right here you can see an example of an otherwise complicated scripting effort. The organization I'm showing here has 3 departments configured: marketing, engineering, and SQA. What we're looking at here is an overview of what is currently going on in all of my data centers across my entire organization in real time. You can also see current performance levels, current latency, and current capacity utilization, and the effectiveness of Nebulon's data reduction technology. You can also witness some AI being applied, which predicts the earliest date when any of the MPods in the departments will run out of capacity. Imagine you had to query each and every storage array, hyperconverged cluster, or SDS cluster individually and aggregate all of that information. That process would take a while, is error prone, and by the time you've collected it, it's probably already out of date. Here you can see all of that information in real time with high confidence without any customization or scripting effort. I want to bring your attention to the control panel on the left side, from which you can select what type of information you're interested in. As an example, you can show more information about real-time performance or historical capacity information. This will instantly change the information that's presented on these cards. The more interesting control, however, is aggregation. You can change the aggregation from current selection, for example, to data centers, and you can immediately see capacity utilization per data center. You can slice and dice your data and reports as you need it. For example, now I can show utilization for each department per data center. Or you can aggregate it all and see everything that's currently happening in your entire IT infrastructure. It's a pretty powerful set of tools. Let's have a look at an individual MPod. Each MPod is its own application cluster. Customers would create an MPod for a VMware cluster, for a Kubernetes cluster, for a NoSQL cluster, etc. And if you want to troubleshoot a specific MPod, you can do so by double-clicking on the specific card and start drilling down on performance and capacity and get all of the details of it. Nebulon is not just a reporting tool. You also use it to provision infrastructure. You can do that from the admin section on Nebulon On. One of the goals that we had is that application owners don't need to worry about storage artifacts or complex storage products. A lot of this complexity we have already eliminated by our unique storage architecture, that being a PCIe card in a server. For the rest, we came up with this concept of using application templates. This is a library of templates contributed by Nebulon that includes best practice storage configurations for various applications. Users can obviously append their own custom templates if needed, but our goal is to provide sufficient coverage for most common applications in this market. What that means is users don't have to know or worry about the best storage setup for their application, but pick the template from the library and they are compliant with best practices. So let me show you how this works. Here I've prepared a VMware cluster composed of 4 servers. As you can see from their configuration, none of these servers have LUNs provisioned, but they all have a Nebulon SPU installed in one of their PCIe slots. Let's take a quick note of this server serial number here, and let's create a new npod from these servers. This is done from the npods page in Nebulon ON. If you click on New npod, you can see the same 4 servers we just saw, but they're not configured. You can see that from the matching serial numbers. You can even see that they're connected to the same switch. To form a new npod, you must first name it, preferably with something that describes the intended use of the npod. You select which department will own this npod, and then you pick one of the templates I showed you earlier. Let's pick this generic VMware template. Next, you select all of the servers that you want to be part of the npod, and as you add these servers, you can see the preview at the top that describes what will be provisioned by use of the template. In this case, we'll get 6 volumes with a total presented capacity of 12 terabytes. Then you click on Validate, where the system will ensure that all of the SPUs in the server can currently communicate, and there are no issues preventing the creation of the npod. And then you click on Create. The npod will now be created. As you can see, this is as simple as setting up a hyper-converged cluster with just a few steps, and what you'll get is all the storage artifacts configured with the best practices for the application that you picked. And here you have the created npod. It's using the 4 servers we selected earlier, has a set of volumes provisioned which are accessible from all servers inside the cluster and can now be used for VMware and the creation of virtual machines. As with every other LUN, you can use VMware tools to create data stores on these volumes, which I will quickly run through. And then finally, you can use this data store for your virtual machines. And there you have it. I hope this demonstration has been of interest. And if you'd like to find out any further information, please do not hesitate to go to www.nebulon.com. Thank you for your time.
All right, thanks team for that. That was awesome. The last thing I'll touch on, just to summarize for our listeners, really why Nebulon. First of all, the next time you're thinking about addressing the needs of your external enterprise storage, Nebulon's going to give you the capability to reduce the cost that you experience every single time you have to acquire that kind of storage. And we're going to do so without you suffering the restrictions of HCI, which many of you well understand. We're also going to give your application owners an ability to experience more of a self-service infrastructure provisioning, storage operations as a service. And in doing so, you're going to reduce the burden on your infrastructure managers. They're going to be able to do more and take on more higher ROI activities. And finally, you get this right from your existing server vendor. No new vendor in your data center, no new contracts, no new support agreements. It's all part of what you acquire from your server vendor. Okay. So with that, we'll close. Thank you all for attending. For those of you interested in learning a bit more about cloud-defined storage, just go to nebulon.com, click on Request a Demo, and we'll turn the keys over to you, and you can actually drive one yourself.
All right, really cool presentation. Really enjoyed that. Exciting stuff that you guys are doing at Nebulon. I've just brought up a poll question for everyone out there in the audience, and we're going to just leave this on the screen while we do some Q&A. We've got hundreds of people on live from across the United States and around the world, and we've got tons of questions coming in. So thank you so much for all the excellent questions. If we don't get to any of these questions during our Q&A session here, we'll do our best to get back to you after the event. I want to make sure that I have all my presenters here live. Craig, Tobias, and CMAC, are you there?
Yep, they're still here.
Awesome. And CMAC, are you still there?
I'm here. Can you hear me okay?
We can, yeah. All right. And Tobias, you're there as well, correct?
I am.
Excellent. Okay. So let's see. We've got answers coming in on the poll. We've got questions coming in from the audience. First question I wanted to ask, Michael is asking, the SPU capabilities are amazing. I have two questions. Are you looking to partner with additional enterprise storage vendors outside of HPE and Supermicro? And let's see, he went on and said, you just answered my second question about DR scenarios due to a loss of network. Who wants to take the first question? Craig, maybe about partnerships?
I can jump in on that. This is Craig here. So we're actually partnering with server vendors. We are a server option on the 2U 24 drive servers. So the partnership actually is not with the storage side. It's just part of the server. And we have HPE today, Supermicro, as you guys heard. We are partnering with a third vendor that we'll announce later in the summer. And even if we're not partnering with a particular vendor that you'd like us to, still love to have the conversation, because we can always approach that server vendor and kick things off with them. We intend to have cloud-defined storage available on every server, every major server vendor on the planet. So.
Awesome. Okay. Next question. Kuldeep is asking, is there an option to just buy the SPU card to install on an existing server? And also, does the host server have to be a 2U 24 drive form factor? Who wants to take that? Tobias?
Sure, and I'm not sure if I've answered that in chat already, but the second question, let me answer the second question first. Yes, initially we're looking at a form factor of 2U rack mount servers, and we're going to utilize, the full, richness that comes in that form factor in terms of number of drives and drives configurations that you can get with these 2U form factor servers. But we're also looking into, what other form factors fit well into the use cases that we're addressing with cloud-defined storage. And so far, when you purchase a new server, that new server will come with an SPU installed from the factory. We're still working with server vendors, with our OEMs, and how we can make it available, or how we can make the SPU available as an individual item.
Okay, nice. Excellent. Let's see. Next question that came in, they're asking here. Actually, it's a follow-up. Can the SPU work for a mix of SSD and HDD storage media?
Sure, so I can. You got that, Tobias? Go for it. It's all yours.
Yeah, so we do support a variety of SSDs with, varying different capacities and sizes. I think between 1 and 4 terabyte initially, and different interfaces. Hard drives is not going to be provided at launch.
Got it. Okay.
Do you want to add to that, Craig?
Question.
Or
we're going for, I think we talked a little bit about, but they're the transactional heavy workloads that really do benefit from the performance of solid state drives, and with the dedupe and compression built into the solution, you're going to find it to be very affordable, especially compared to what you might look at as an external storage array. So, yeah.
Okay.
Definitely.
And I want to bring
Sorry, I was just going to say, definitely take a look at the cost of the SATA class of SSDs in your with your server vendor. It's more and more affordable every day.
Very nice. Yeah, good point. I want to bring CMAC in, and CMAC, this is a good question for you, I believe, and it's just at a higher level here. I mean, why did you choose to start a new storage company with so many storage options available today?
That's a great question. What we were really looking for was not to start another storage company. As you said, there's just enough options. But what we ran into, and in conversations with customers, we felt that there's a broken model where people can't manage their environment at scale. It is complex and expensive to buy a storage array, 5-channel switches and 5-channel cards, and put it all together to do LUN masking. And the software-defined storage had so many restrictions in terms of choices of the hypervisors and in terms of performance restrictions and having to buy specialty SSDs for write cache, that we felt there is really no existing solution today that addresses the needs of enterprises to simplify their infrastructure and also be able to run it at scale like a cloud vendor would. So, and we didn't really start another storage company that builds another storage appliance. We're actually building something that fundamentally shifts the way people, would consume and build and configure and manage a storage. So in some ways, we look at it very differently. And the best way I think about it is that when somebody at an application level wants to use the networking, he doesn't think about networking too much. It's just a network port that is connected. Now, somebody set up everything in terms of the routing and switches, but you don't have to think as the user about networking much. It's just an IP address and a DHCP that shows up. I just want the storage to look like that, right? It has to be just something that is in the fabric and not something that you think a lot about. There's an external mechanism to manage it all, but from an application user perspective, I just want it to be as self-service as possible. And that's what led us to actually build this company.
Very nice. Very nice. Okay. And I mean, this is super exciting. Tons of questions coming in. Next question here. What about remote data replication features for disaster recovery?
We absolutely have plans to, release a product that does that, really, update our software to do that. At GA, we don't have that functionality. While we're working on the functionality, we expect that function to be available soon after next year.
Nice, nice. Well, that's exciting. All right. Next question. Gary is asking, I see the Nebulon PCIe card showing as branded Nebulon. In real life, when it's released, will it be branded perhaps something else like HPE or SMC?
Yeah. This is Craig here. The way that would appear, it's going to appear as a server option under your HPE or Supermicro server. So we'll have an HPE SKU, a Supermicro SKU. It'll be quoted accordingly. So it'll look just like any server option associated with those platforms.
Okay, nice. And then how do I protect my cloud-defined storage? That's a question here from Rahul. How will the data be protected from loss? And maybe those are two separate questions. I mean, one is how do I protect it from loss just locally on premises? And then how do I protect it if, say, my data center is lost? Can I use a traditional backup application with it?
Yeah,
So
let
let's
me
talk about
take a step. Oh, you go ahead, Craig. CMAC, sorry.
Go on.
Yeah, so yeah, let me give it a first try, and you can color it in a bit more. So the applications that we're targeting, they typically have already a backup solution in place, right? And traditionally, you can use a backup software with a backup agent that you install on the application clusters, and you use that backup agent to create application-aware copies and backups of your application. There's nothing specific about cloud-defined storage that requires you to have any integration with any of those, but we're working towards a more tightly integration with these ISVs to accelerate the data protection and the recovery times of those applications. And the other thing that was really asked there is probably related to the previous question in terms of data center loss, right? Where we do have plans for implementing replication for really implemented business continuity, to prevent you from data loss. I'm not sure, CMAC, if you want to add more color to that.
No, I think that was good. I mean, we do have the combination of, as you said, erasure coding on a parent view basis, then mirroring across the pod. That's kind of the local data center level. We will have disaster recovery next year, and the only thing we actually store in the cloud is just the metadata, and that's actually stored in multiple zones. And even an outage in the cloud or an issue with the cloud should not cause loss of access to that metadata or management interfaces that we have in the cloud.
Yeah. One thing that I would add to the conversation, so since we started talking about things that will come after the initial release, because we are, this cloud-based control plane, we can introduce cool new features. For example, at GA, we will not ship with stretch cluster, but that's a really interesting capability for a platform like this. Stretch cluster is going to be delivered as part of the control plane, so there's no real need to do any kind of updates on your side. So kind of like Gmail, or for any of you out there who drive a Tesla, your overnight update, you hop into your car and you've got new features. That's what this is like. You will, stretch cluster is a great example of a feature that will just be there once we have posted it to the cloud. So very different kind of experience with storage, given the way we've done this.
All right, excellent. Well, I'm afraid we're running out of time here in this Q&A session. But what we're going to do now is I'm going to announce our first set of prize winners. We've got a number of gift cards to give out here. And then we're going to get, camera ready. And Scott Lowe is going to introduce us. And then we're going to jump in and do some live video. And we're going to chat some more about this. We're going to take some more live questions from the audience. We're going to keep answering as many electronic questions as we can. So keep those coming in. We've got hundreds of questions. We're doing our best to get back to all of them. So really good Q&A session here. Let's jump in just a second and do some video. But first, I'm going to announce our 9 Amazon $100 gift card winners. So we've got 9 Amazon $100 gift card winners. We'll reach out to you after today's event via email to deliver these. It'll take me just a second to read all these. I'll post them in the questions window as well. We've got Ben French from Texas, Edward Podolsky from Illinois, Garth Hemmer from Indiana, Jason Fuse from Virginia, Sachin Sood from Kansas, David Tu from Washington, Mike McShane from Minnesota, Devon Deharian from South Carolina, and Sho Amoto from California. Like I said, I'll post all those in the questions tab there, so you can review the names if you thought I called your name, but maybe not. So check out the questions tab, and there's a lot more answers coming to all the questions that are coming in. All right, so now we're going to jump into our video booth here, and we'll see you in just a moment on video. I'm excited to begin today's panel discussion, and I want to kick it off by congratulating you all on the launch of Nebulon. It's got to be a great feeling after so much work that you put into it. A really excellent presentation, excellent demo. Thank you so much for being on the event today. We've got a lot of good questions coming in from the audience, so let's kick it off with the first question. And let's see, that is, you mentioned self-service infrastructure provisioning. Can you tell us more about this? And I'll hand that over to you, Tobias.
Yeah, sure, absolutely. So our approach to self-service infrastructure provisioning really starts with our application templates that I mentioned during the presentation. They are curated, reusable definitions of server to storage configurations, and they are tailored for specific applications like VMware, Kubernetes, MongoDB, and there's more to come over time. Now, these application templates are used to help deploy infrastructure in a repeatable and in a consistent way. And that is true for organizations that are just starting out small, or if you're doing infrastructure provisioning at very large scale. Now, the template does quite a lot of things for the application owner or the user that is self-service provisioning infrastructure. The template automates things like the number and the size of volumes, the data redundancy, the data protection settings, the snapshot schedules, which servers have access to which volumes. And this is all done under the covers of the template. And the customer or the user doesn't really have to think much about what's going on. We also are able to provision the boot volume, and we can load the operating system image if it is provided by the customer, meaning they provided a URL to a golden boot image. So when a user self-service provisions infrastructure, the customer really just racks their servers, they power them on, they select the appropriate application template for their application clusters, and then in just a few minutes, the storage, the server, and the operating system assets are all ready to use for the application owner.
Okay. So these self-service templates really make provisioning of storage easy for a long list of different enterprise applications. Is that true?
Absolutely. Absolutely.
I like it. All right. Let's see. Next question that came in. They said a lot of vendors offer a cloud management solution for their storage. What's really different about cloud-defined storage? Back to you, Tobias.
Right. Yeah. So you're absolutely right that some external storage vendors do indeed collect telemetry from their arrays for cloud-based monitoring, for alerts, proactive support, to help with troubleshooting the storage arrays. However, most of these storage solutions still rely on an on-premises management console that is running somewhere in a control station in the data center. And they need that to do any administrative work. And now you have this kind of split brain problem between this remote monitoring that sits in the cloud and the on-prem administration. And that disconnect that can introduce delays, and it can introduce actually human error. Now with Nebulon and Nebulon's cloud-defined storage, we collect tens of thousands of metrics across the server, the storage, and if the customer has it enabled across the applications that are running on these servers every hour, and we do that across the entire infrastructure that a customer owns. And we then combine AI ops with centralized infrastructure management, and with that, application owners can not only view and see the issues, so they have the tooling that is necessary for not only the detection of these latent issues, but they also have the facilities to actually correct them, and they have that all in the same tools. Now, to use other words, right? It's one thing to point to a fire, and it's another to really put it out.
Okay, I like that. I like that. Very nice. All right. Next question is for you, CMAC. They said that you mentioned cloud-defined storage is for on-prem data. So at some point, will you at Nebulon be able to support data in the cloud?
So that's a good question. The fact is that the way we think about enterprise IT, we really think of them as really service providers for the enterprise, right? And essentially they're running their own private cloud. And there are other types of service providers that I think would be a perfect fit for our solution. If you're talking about the hyperscale cloud vendors, I think as time goes, we will assess the market fit and the customer demand. And architecturally, we will obviously be able to run our solution in the cloud, like a hyperscale cloud. But the question is there demand? Is there a pull to actually provide such a service in the cloud or not?
Okay, interesting. And then another follow-up question here. They said with servers CPU increasing in performance and cores every year, is it really necessary to offload those CPUs with your SPU?
So the fact of the matter is that the CPU cores aren't getting any faster. The frequencies have remained constant for some time now. And people just keep adding cores. Number one. Number two, the speed of memory isn't really increasing. So what happens is that becomes a bottleneck. You have more and more cores trying to get to the memory. It's all bottleneck behind memory. So, and it doesn't really change the fact that if you try to put the software on the server, it still creates an environment where the operating system and the storage services software can collide and interact in undesirable ways and create a firmware update problem where if you're trying to update one firmware, it impacts the other one. So keeping those separations for availability, and also the fact that adding more cores does not necessarily translate to more performance, leads you to, in fact, this is a trend you already see. If that was the case, why are we still having GPUs to do AI? Why don't we just use more of those cores that are available, right? The fact is that at some point in time, adding those cores isn't really buying you much.
Okay.
David, and another take on that question too is what we're doing is not just offloading the server CPU, but the memory and network resources, the server as well. And so, part of the issue, and CMAC touched on it with memory, is as you get more cores and you want to load up your servers even more, at some point you're going to hit a boundary in terms of how many VMs, how many databases you can load on an application server. The idea is if you take the IO processing off the server, you absolutely will be able to run more of your workload, more of what you purchased the server for on that server. And put yourself in the shoes of an organization with hundreds or even thousands of servers. If they have to, take on 20 or 30% more CapEx and OpEx to add servers to deal with their application infrastructure, that's a huge bill, of capital equipment and operating expense for them to deal with. Offloading the each of those servers with the appropriate technology is absolutely a cost and time saver.
Absolutely, yeah. I mean, there's so much more to the cost of the servers, like you mentioned, than just the CapEx. You have the ongoing operational expense of managing hundreds or potentially 1,000 more servers in the data center. So, Craig, I'm curious, what's the customer reaction been to the new solution?
It's been my favorite part so far. We've talked to now dozens of large organizations, and I thought maybe tying it down to a few specific companies might help. Let's see, one large auto manufacturer. They've said that they've begun to shift their focus from traditional storage arrays to server-based storage, but with CPU being the one resource they can't afford to give up on their servers, their options have been limited because, of course, HCI is going to want 20, 30% of that. And so, from their perspective, our approach with cloud-defined storage sounds like kind of the right technology, right time to help them get to their goals. A financial services customer has broadly deployed one of the big HCI platforms. They're having real problems with endpoint software and firmware management. So think firmware updates of the SSDs inside the servers. Every server has 10 drives. They have 1,000 servers, 10,000 drives. And those firmware updates need to happen, every so often. And when they don't happen, they experience very inconsistent performance across their infrastructure. And that's something that, again, we address with the push of a button. So, that's a big issue for them. They love the sound of that. Another large financial who also has a fair bit of experience with the leading HCI platforms had commented that this kind of solves the issues they've had with HCI regarding maintenance and reliability, and for them separating, in their words, the storage code from the OS is such a smart idea because it materially affects their service levels. So I think, for folks who are, grown their infrastructure on arrays and trying to facilitate the shift to a more cost-effective server-based approach, and understand, where the limits are vis-a-vis these, different HCI platforms, that they're going to take a look here and I believe find something really compelling.
Excellent. Yeah, I mean, when you talk about those challenges with HCI, I bet that's something that a lot of companies don't think about when they initially look at HCI. Is all these, firmware upgrades that have to happen in the massive scale that it would have to happen at in a very large data center.
Yeah, for sure.
So given what's happening in the world today, I can imagine organizations really looking to help mitigate some of the impact. How can cloud-defined storage help them?
Yeah, David, it is it's a crazy time right now. People say the new normal, and that's no joke. I think for kind of where we are right now, there's three big ways that cloud-defined storage can help folks. First, like we've talked about, in sort of unsettled times, organizations are looking for ways to kind of reduce the CapEx pressure on the business, and with this value proposition of being able to save folks up to 50% of their storage CapEx vis-a-vis arrays without the restrictions of HCI, that has to really kind of give a look, because that's going to be so important going forward. Number two is helping folks with operating cost pressure. A lot of organizations have already consolidated IT admin roles. So, a given individual is now responsible for the whole of the infrastructure in some cases for certain applications. And sadly, storage still continues to occupy an unfair amount of their administrative time. One recent study I saw suggested that cloud-based management of storage allows admins to cover twice the infrastructure in half the time. So that's a 4x productivity improvement. And so that's something that, again, I believe folks have got to take a look at. The third bit is, kind of down to some of the restrictions we've all felt related to travel, social distancing, on-site personnel, policy changes. there, that those factors are already driving a desire for greater levels of automation, remote management, including things like lights out server storage provisioning, flip this group of servers from maybe a VMware development environment to a container development environment and do that simply and in minutes. Handle software and drive firmware updates remotely, nothing on site, push a button, done. Even the trial or POC, let's call it, of cloud-defined storage is a cloud-based approach. It's not something that you've got to wheel into the data center and physically touch. It's cloud-based, can be done securely, from any location, home or office. So those are a few things we think, really enable folks when, when they're looking for different answers to, the same age-old questions.
Absolutely. Yeah, it sounds like this is a solution that can help so many companies out there. I'm curious, what should people do to get started?
So the thing I'd suggest is to, go to the website. There's, lots of assets there that, you can click into and learn a little more about what we're up to for your application. A little more about the technology, but I think the best and easiest thing to do is, to request a demo. Takes just a few minutes. You'll see, instead of a presentation, you'll actually see it in action and be able to speak to someone and see if it's a fit for what you're doing. So that's probably the best bet.
Absolutely. Yeah, it sounds like a really exciting new solution. I want to do the demo for myself. I want to see this in action. I know a lot of the folks out there in the audience do as well. Thank you so much, Tobias, Craig, and CMAC for your presentation and for this discussion.
Thank you.
Yeah, our pleasure.
I'm happy to talk about Nebulon from an analyst perspective. Simply put, what is cloud-defined storage? Well, it's the next evolution of software-defined storage, and it fully separates the control plane from the data plane in ways we really haven't seen often before. In this context, the control plane exists as a cloud-based software as a service offering that manages the data plane. And that data plane is comprised of on-premises service processing units in Nebulon speak. These are called SPUs. What are the benefits to this separation, the way that Nebulon has approached it with cloud-defined storage? Well, first of all, you get a SaaS approach to storage management. And at first, you may kind of think, really, what's the big deal? I can manage storage right now just the way I always have. Well, when it comes down to things like software updates and data aggregation for monitoring and statistics and all that good stuff, you start to see what some of the potential benefits are to a SaaS approach. SaaS is upgraded by the vendor on an ongoing basis, so you're always getting new features and new capabilities that you may not have had before. And with Nebulon, aggregated metrics from across your environment bring incredible analysis and forecasting capabilities to bear that can be very difficult to get when you're in an on-premise or traditional storage environment. And when you think about many storage environments, they're often wildly distributed and not always as cohesive as we'd like them to be. With Nebulon, we have truly centralized administration, which can bring new opportunities for planet-scale storage deployments and self-service capabilities that I'll talk more about later on. Nebulon has taken a security-first approach as well to ensure that the SaaS tool is as secure as on-premises storage management. When you start to think about cloud, often security becomes a limiting factor for some organizations, and we don't want to see that. So Nebulon has made sure that they've tightened up the security elements in their solutions so that it's not a worry. When we think about some of the business and technical outcomes that we expect to see from something like Nebulon, there are some things that really jump to mind. The first is workload flexibility. A common storage platform that provides support for virtually any type of workload bare metal, virtualized, or containerized workloads really has a leg up on a mishmash of other storage technologies that can imbue your organization with a lot of complexity. There's also operational efficiency and ease of use. The SaaS approach eliminates control plane upgrades and management upgrades. They're done by Nebulon. And you get aggregated statistics from across your entire environment that you can slice and dice, which is really powerful. And you saw that in the demo earlier. This can provide actionable insight into operations, and you can make better decisions about how to move forward. You can also enable self-service capabilities for application owners, which brings additional agility to application support. Now, on the operational efficiency and ease of use front, Nebulon has also done a couple of other things. They're not selling you their card, their PCIe card that goes in servers. You acquire the solution from an existing server vendor so you can avoid disruption of your current relationships. And with their tool, you can get comprehensive reporting with all kinds of roll-ups available to you to view storage capacity, performance, and other real-time statistics, including capacity planning, things that are really important to understand so you can make sure that your storage environment remains highly available. We also have to talk about improved automation capabilities. Nebulon's AI-driven workload recommendations and single API access via the cloud mean that you have a single point of contact for everything to do with storage. There's no juggling of internal IPs for your developers and things like that that may want to access APIs. If you think about APIs for on-premises IT infrastructure, they can be kind of a mess sometimes because you have so many points of entry into the infrastructure environment. With cloud-defined storage, you have a single cloud URL that you use for all API calls, which makes it eminently simple to deploy programmable infrastructure and get your infrastructure into the hands of your developers. And for many, cost containment is a key issue. Through a combination of commodity hardware, increased density of workloads thanks to removal of control plane and CPU overhead, and SaaS simplicity and common workload platforms and all the other ease of use things that Nebulon and cloud-defined storage is bringing to the world, you start to see ways you can reduce costs. And we'll talk more about that later on. If you're looking for storage today, it's probably fair to say that you're also looking at software-defined storage and hyperconverged infrastructure solutions. And these are strong contenders in the data center, and they've spawned lots of spin-offs like disaggregated HCI and also evolutions such as composable infrastructure. But both of these technologies still have certain shortcomings in some cases that can be addressed with cloud-defined storage. The first is around availability. When you think about software-defined storage or hyperconvergence, if a server goes down, you're going to lose access to the storage that exists inside that server. With cloud-defined storage, as long as it's an operating system fault, not a hardware fault, an OS malfunction doesn't bring down storage. But the real benefit comes when we start talking about performance and workload density. Cloud-defined storage eliminates the need for host CPU overhead to handle data services such as deduplication. This is all handled by the card that's separate from the CPU and RAM in the server. All of this serves to enable pretty significant expense reduction. You get more workloads per host, and there's no need to buy per host hypervisor licenses due solely to storage overhead. Also, don't forget, cloud-defined storage operates on commodity hardware, so you get some economies of scale from using commodity hardware that may not have a premium attached to it like many storage solutions out on the market. And then there's flexibility. Any workload, anywhere, from bare metal to virtualized to containerized, it's all without special software support needs in the host operating system. So I talked a little bit about how the control plane, the SaaS tool that operates in the cloud, provides some benefits to organizations. But that won't work without something on premises actually dealing with the storage layer, the data plane, as it were. And this is the role of the Nebulon Services Processing Unit, or SPU. This is essentially a server inside a server, and is dedicated to managing all of the storage inside the host server. So rather than the disks being attached directly to ports on the server, they're going to be attached to the SPU. And this means that the SPU is going to handle managing all of that storage. And this host server doesn't have to do that. It can focus on managing workloads, which is what you want. In the world of Nebulon, The SPU is a full-length, double-width PCIe card that goes right in the server. Each SPU has a pair of 10 or 25 gig Ethernet ports for intercard communication and really to scale your storage environment. Each card also features a 1 gigabit Ethernet connection for the management network. Each card also has 8 CPU cores and support for up to 24 drives per SPU, with each drive being up to 4 terabytes in size. The SPU handles all of the data services, including deduplication, compression, erasure coding, encryption, snapshots, data mirroring, and more. The SPU is really where the storage magic happens, but the brains are in the cloud. And you don't have to worry about things happening on the host server. So if you're running a virtualized environment on VMware and ESXi crashes or something like that, the SPU will remain operational as long as it's just a host OS crash or the system becomes otherwise unavailable due to a software error. In this case, the SPU remains available and all of the data that's stored on that node remains accessible to that SPU as well as to any other authorized SPUs in your environment. The real beauty here is that the SPU essentially offloads a lot of management overhead from what would have taken place in CPUs in other types of environments. As I mentioned earlier, this can reduce a number of licensing costs since you don't have to buy hypervisor licenses as you try to scale. Now, it's important to note the servers are managed separately from the SPU for things like patching and things like that. This provides easier administration. But what do I mean by that? Let's say you want to install the new version of vSphere. Well, in a hyperconverged infrastructure environment, you would have to take a host down, install the new version of vSphere, and then bring that host back up. During that time, the storage that's on that host would not be available to the rest of the cluster. This is not how things work in a cloud-defined storage environment from Nebulon. The time you have the server down due to doing something along the lines of installing a new operating system patch or what have you, the SPU remains available, as I mentioned before. So this provides you with separate administration capabilities and allows you to actually administer your workloads, your application workloads, your software workloads, without impacting your storage environment. And one of the really nice things about the SPU is, although it's powerful with 8 processing cores, it's really a relatively small I/O stack. It's just operational bits since the real brains are in the cloud managing the SPUs. At general availability, you can actually have up to 32 SPUs in a pod that provide petabyte scale storage to your environment. You also get the capability for various storage configurations to support a variety of workloads. Every workload operates differently. Some applications have their own built-in write verification mechanisms and things like that, so you don't need the storage to do it. With cloud-defined storage from Nebulon, you can tailor the storage environment to the application needs. Now, one of the beauties of cloud-defined storage from Nebulon is its reliance on commodity hardware. Now, the storage media in the servers is also commodity storage, all connected to the SPU. Now, what does this mean for you? A lot of organizations have long-standing relationships with server vendors. I know that I've talked to a number of people, for example, that have HPE servers and they will never go to anything else, and that's because they're good servers. For these customers, there's no need to create new partnerships with a different server vendor just because you want to use a different storage solution. As long as your server vendor is supported, you're good to go. And over time, expect to see Nebulon add support for additional server vendors. And the commodity hardware approach brings some financial benefits. There's some economies of scale you can achieve that you just don't get with specialized hardware. So, what are your next steps? Well, let's talk about IT architecture for a second. When we think about IT architecture, 10 years ago, there were teams and hordes of people around to manage the infrastructure. Today, those people still exist, but organizations are looking for people that can marry that infrastructure, the architecture of the IT environment, to workloads, to things that are customer facing, to a development team so that applications can be more self-managing. Really, IT architecture is ripe for transformation. For years we've heard terms like programmable infrastructure and things like that. It's a real thing when you start thinking about bringing your architecture, your infrastructure, into the context of a CI/CD pipeline, for example. As we move into an era that's increasingly blurring the lines between applications and infrastructure, really it has to become more fluid, more composable, more programmable. Although the days of just jumping into the cloud just because are over, you can still smartly leverage the cloud in a hybrid way to bring scaling benefits even for on-premises infrastructure. And that's something you get from cloud-defined storage. And when we think about other options that are out there, such as software-defined storage and hyperconverged infrastructure, they're great options for a lot of people, don't get me wrong. But as you consider your path forward, it's important to look at everything that's on the market. And as such, cloud-defined storage should be on your evaluation shortlist if you're looking at a storage refresh, and if you're looking for something that can support all of your workloads across your environment. Cloud-defined storage's commodity-centric approach is really fully decoupled the control and data planes in the storage environment in ways we don't often see. And this can bring long-term and significant scaling opportunities that can sometimes be difficult to achieve with other solutions. Thank you very much for listening to this short discussion about a little overarching view of cloud-defined storage, and I look forward to talking to you more about this technology.
Great insight from Mr. Scott D. Lowe. Now it is time for our big grand prize giveaway. We have a prize winner for the really cool bike. This is actually a Rad Rover electric bike, 500 watts, 48 volt, lithium ion battery, 275 pound payload capacity. Needless to say, this is an awesome bike. The prize winner of the Rad Rover bike is David Kearns of California. Congratulations, David Kearns of California. We will reach out to you. Actually, Nebulon will reach out to you to deliver your bike. Best of luck to everyone on a future event. If you didn't win today, we've got a lot more events upcoming, of course. After this, you'll be redirected to our events website. But before you go, I want to remind you to check out the handouts that are available for download there in your audience console on the handouts tab. It's there that you can download the 6 things every app owner should demand from their data storage, and also how storage is still the weakest link for IT admins. Make sure you check out those resources from Nebulon. And of course, visit Nebulon for more information. Watch for a follow-up email from Nebulon with a link to today's recording, as well as a number of other resources and a special link for you to try out the Nebulon solution for yourself. Thank you, everyone, for joining today's special Nebulon launch event, The Future of Cloud-Defined Storage. Have a great day.